Hey everyone, my name is Alex. I'm a master's candidate here at Columbia in the Department of Electrical Engineering. And for my research proposal this semester, I'm going to be doing speaker diarization. So before I get into the details of what the project is going to entail, just going to do a really quick problem statement. So kind of describe what the problem is. So speaker diarization, if you can imagine you're watching Good Morning America and the news anchor starts talking about the news and then they hand it over to someone else doing the weather. Maybe this is another speaker. And then the person who's doing the weather talks for a few seconds and then they say, and back to you, speaker A. What if we had to do this automatically? So we have two different speakers or maybe n different speakers in time. We want to automatically be able to tell who's talking when. This is the fundamental problem. And then instead of using raw audio, maybe we extrapolate some features out of those. So this current state of the art is we have two really different models that I'm looking at. LIUM, which is a Gaussian mixture model using MFCC features. This is a 13-dimensional feature vector that it gets extrapolated from that raw audio. And there's several different implementations of this in Caldi. A second one is a deep recurrent convolutional neural network model. So this actually, instead of using FCC, used a short-time Fourier transform approach called the constant Q transform to get a 96-dimensional vector that fed into this recurrent model, and they implemented this in Python. So kind of combining these two ideas is really what I want to go after with this project. And the data set that I'm using for this is three different ones: YouTube, AMI, and ISCI. So this is between 50 and 1,000 speakers and a couple hundred hours worth of recordings, all labeled with who's talking when. So the proposal for this project is going to be three-pronged approach. First, I want to take a Gaussian mixture model using one of the existing scripts in Caldi and use that as a starting point, and then try to train this GMM based on a wider data set than we've done before. So I'll use the three data sets mentioned previously and extract out this QCT features. So this 96-dimensional vector, maybe this fares a lot better than the 13-dimensional MFCC. So I'm going to retry the Gaussian mixture model with this new data set, see if it does any better. Then I'll add in some disturbances, so pops, music, multipath, anything that is going to kind of disturb and try to obfuscate the speaker. And then kind of compare against how does this do against the clean data if we have some sort of disturbances in the background. And then lastly, as a stretch goal, if I can implement a deep learning model, either a CNN or a recursive CNN, similar to that second state of the art that I mentioned, that'd be really great. And then there's a deep neural network support, and then three, you can check out the documentation for that in Caldi already. So maybe I can leverage some of that. So that's then the proposal, and thank you.